I'm presenting BIM adoption for structural engineering design in collaboration with Professor Caputi, Supervisor Professor Caputi. We have the thesis structure from introduction, theoretical backgrounds in BIM, BIM adoption for structural design, case studies, and conclusions. So the intention of the thesis is to explore the developments, benefits, and application of BIM, BIM adoption in general, and then with focus to structural design discipline for cast in place and reinforced concrete buildings. In general, was identified the structural engineers are positive to BIM adoption compared to the other disciplines. So structural thesis, we begin with introduction to BIM. We've been researching historic BIM, its main developments, then going to maturity assessment models, challenges, trends, benefits, business strategies, investment in BIM, and integrated workflows. Also has been built 3 different scenarios, including traditional design, IFC exchange, and integrated modeling workflows, making use of Revit robot software, Revit Sophistic, ProSap, Tekla structure design, Tekla structures. So it is done a survey to take into consideration the opinions of the other professionals in the field. And all information has been analyzed and evaluated towards BIM adoption maturity assessment models. We have the general thesis structure. So we started with historic BIM by making analysis on the identified research, starting from we have been from Charles Eastman with building description system, composing of data structure and schemas, and integration of graphical information and non-graphical information. We have the different BIM maturity levels that most of us very well know. Different research has been analyzed for the BIM adoption. It is mainly focused towards project level, organization level, or towards the individual competencies. This is the research from Bright et al., which has been evaluated 35 BIM adoption at project level and evaluated positive for benefits obtained criteria and negative if it was identified the limitation or barrier. So in general, it was seen that with BIM we have cost reduction, time reduction, communication improvement, coordination, quality increase, and with issues with organization and software. So maturity assessment models have been carefully analyzed. We have started from individual focus projects and organization level. Challenges, lack of experience and skilled personnel was identified as main challenges, which includes BIM, which includes people. We have people are main challenge in BIM adoption. You need training for professionals involved in BIM. Skepticism may still be present. You need policies at organization, also national frameworks. You may have higher initial costs, which are expected to be overcome by future benefits. You need the higher accuracy of the BIM model. You need the full BIM model in order to generate the project documentation. And you may have challenges in interoperability, standardization, and trust between the different actors. It was also seen that a lot of companies have been already adopting BIM. This is a survey from OICE, Organizzazione di Ingegneria di Consulenza, which has identified that 86% of Italian engineering companies have already done investment in BIM. We have good utility and efficacy identified for more than 60% of the interviewed, and with satisfied. And we have high satisfaction for 30% of the companies and 60% of high satisfaction for small and medium companies. Also, the role of BIM professionals was identified and evaluated positively. We have with BIM, we have benefits, numerous benefits, starting from use rework, accuracy, quantity estimation. You have higher production, efficacy, a higher value, design quality, you have better communication, and so on. Also, from the economical point of view, generally we have the ROI coefficient, which evaluates how much you are benefiting in economical term from and how much you are saving from using BIM compared to the initial cost. And generally have been identified high values. You need integrated workflows, you need connected processes and activities in order to have BIM adoption. For structural engineering design for specific discipline, it is generally been identified there is the lack of research and BIM research has been mainly in coordination and management. For this thesis, we have built the three scenarios, starting from traditional design, where you have no specific digital collaboration, then to IFC exchange, which make use of interoperable format exchange, and integrated modeling for CD common data environment. The workflow and scenarios have been further detailed for traditional design and applying the business process re-engineering, BPR, to IFC exchange, and integrated modeling, specifying all the duties and responsibilities for all the actors involved in the process. When you start speaking of BIM, you are going from structure design to information modeling workflows. So we have from physical modeling, analytical model definition. We have the particularity of structure model, which consists of structure analysis, code checking, detailing, model deliverables, class detection, and so on. We have the different software integrated in workflows, which has been used, starting from Revit Robot, which make use of adding tools, adding commands for information exchange by mapping the different structural elements, and also allow the information exchange for not only the models, but also for loads. We have for design, and also for results, including the reinforcement detailing. We have Sophistic, Revit Sophistic. Sophistic comes as an adding tools and allows direct information exchange within the software. So has been used in Italian software. We have ProSAP. It is, I think, in the first steps of BIM adoption. It makes use of import, update, export operation for IFC formats and some additional tools for increasing the BIM interoperability. Then we have Tekla Structure Design, Tekla Structures, which has been identified as very good in all operation and processes for design and information exchange. So interoperability has been analyzed, making use of IFC models and the CXL formats, which increase the interoperability and is being used mainly from Tekla we have here and Revit. All these scenarios and the workflows, integrated workflows, have been applied to specific case studies. We have from first one was an academic model which we built during the BIM program. Then we have 3 case studies here, which are mainly composing the case study number 2. The first one is making use of traditional workflows. The second one is IFC exchange, and the third one of integrated modeling. These are real case studies, and they've been analyzed for the process involving structural design and information modeling. For all design of all structural elements, have been built specific workflows with all the analysis, design, detailing reported in the thesis. So we have advantages and disadvantages for every of each one of the specific software and workflows. So, for example, Revit and the Robot and Sophistic, they make use and allow to have direct 3D reinforcement detailing in Revit. ProSAP, it makes use of this IFC information exchange and applies some additional add-in tools. It has this. It does not include 3D reinforcement detailing, but mainly the 2D information and detailing for the reinforcement. In Tekla Structure Design, Tekla Structure, we analyzed all the analysis, design, and detailing process. For mainly Tekla Structure Design is for analysis and design, and then we have the detailing and reporting from Tekla Structures, which directly recognize all the information from Tekla TSD, Tekla Structure Design, and automatically generates the 3D reinforcement of detailing. All these case studies have been analyzed from some choose analyzing criteria. So we have from structure modeling capacities, accuracy of physical model, low definition combination, analytical model configuration, analysis design, detailing functionalities, process automation, interoperability, and so on for each one of the processes that involve the structure design and information modeling. The case study number 2, we have also here analyzed in detail also at an organization level for information exchange. Here we was applied initially, this is already built building and was applied traditional workflow, so it was possible to compare the improvements that were obtained in the structure in the case study number 2B, which was improved for IFC exchange for workflow and formats, and with the introduction of the BIM coordinator BIM coordinator profession. Also, this case study was analyzed for all the processes involved in the modeling, import, export, for analysis and design process, and for automation within all four software and integrated workflows. So in this case study, we has been identified and analyzed for the choose criteria, every specific workflow for every advantages and disadvantages that they were introducing in the process. Also was possible to make a comparison. For example, now in the building A that was traditional design, there were clashes identified late on site between the different design disciplines. Instead, with building B, it's great to not have clashes since it is making use of the IFC exchange and for clash detection between the different discipline models. Case study number 3. So here we have built for every specific modeling process being the detailed workflows, also for analysis, design, and detailing. The case study number 3 had a higher project complexity, and it was defined that generally all software are dealing well, mainly Tekla, and with some limitation in ProSub. Also here have been reported all the new issues for the modeling, interoperability, analysis, design, and detailing. Also, it was done a survey for all the processes involved structure design, a survey for different professions in order to have opinions also of other people that are working in the field. The results have been also parameterized to have a better idea of the evaluation. So at the end of the study, we have introduced a new BIM SLUA model, BIM structure design workflow assessment model. So in the general, the maturity assessment models are toward project, organization, or individual competencies. And here we are going into a specific discipline. So we have the BIM structure design workflow assessment model. So for the specific structure design discipline, and have been applied to all the analyzed and discussed criteria during the case study. So conclusion. So it's mostly all the issues that have been identified during the case studies, and have been summarized into a final table, including the application of the BIM SLUA workflow and maturity assessment model for each of the evaluation criteria, and with the specific result for every integrated workflow. Thank you.